Okay, so we're going to continue on grade 10 with systems of equations.
Was that homework?
Oh, okay.
Yeah, it was.
It's
Totally.
on me, actually.
I know, I saw it.
Okay, grade 9's on recording, so you just have to. So with the graphing stuff yesterday, you guys might have noticed that like sometimes your answers don't totally line up perfectly with what's in the back of the book. Sometimes your graphs could be off a little bit. It's not the best way about going about things. So what we're going to do today is we're going to start. So it's 7.4 in the textbook. We're going to skip 7.3 for now. So we're going to start solving systems. With substitution. Yes. Okay. So, when you're solving systems with substitutions, what you'll need to do X, you need to get X or Y from one of the equations alone, or isolated. Okay, so you need X or Y all by itself. Okay? Then you just substitute that into the other equation. Substitute into the other equation. And solve. Cadabra, cadabra. And then it's all done. So let's start with one here. Three x plus 4y plus -4. And x plus 2y equals 2. Okay, so here's my two equations. So instead of graphing these like we were yesterday, we're actually just going to do substitution. So remember the first part of what we wrote down was you need to get x or y from one of the equations isolated, so all by itself. Looking at these two equations, which x or y from either one of these equations would be easiest to get alone?
Second x.
The second x, very good, okay? So let's take that equation now. Let's do that, okay? So it's going to be x. All I'm going to do, let's rewrite it here. You don't have to rewrite it all these times like I do. But to get the 2y over to the other side of the equal sign, because it's positive 2y, I have to subtract, right? So it just becomes so I have that equation, and then I was already given this equation here. (3x plus 4y equals -4, right? Now, I know what x equals, don't I? Here it says x equals 2 minus 2y. So what you can do is you take this here, you plug it in for x there. Okay, so it looks like this. If I substitute, we're doing substitution today, 2 minus 2x in for x, or 2 minus 2y in for x, it's going to look like this now. 3 bracket I plug that in for my x value. Does that make sense what I did?
You're not actually taking the twos, subtracting from the twos, just rewriting them.
Right. I can't subtract 2 from 2y. They're not like terms, right? I just rewrite it so x is alone here. And then when I have x alone here, I plug whatever I have on this side of the equal sign in for x on the second equation. Okay? Now that I've done that, I have all of this here. I work it all out. So I do my FOIL here. So it's going to look like this. 6 minus 6y plus 4y equals -4. Now can I solve for y here? Can I figure that all out? I can start combining like terms, like -6y plus 4y, and 2y. I can bring the 6 over to the other side by subtraction. -4 take away 6 is -10. Divide by -2. Y equals 5. You guys see what I did there? Kind of? Don't worry, we'll do more examples. Now, once I solve for y, I need to solve for x. Okay, so I'll take the y that I found here, and I'm just going to plug it back into one of my equations. It's always easiest to plug it back into the one here that you did the first little bit of maneuvering with. So it's just going to be x equals 2 minus 2 times 5. Two minus 10. 2 take away 10 is 8. All right, and those are my coordinates now. My x value is -8. My y value is 5. Now, real quick, you just take one of the two equations from the very beginning here. One of these guys here, doesn't matter which one, and you do the check. So you plug in for x and you plug in for y. Where am I going here? So I have the one equation, x plus 2y equals 2. Same thing? So I plug in, I'm doing my check here. So this becomes -8 plus 2 times 5. What's -8 plus 10? It's 2. Is this right? Boom! All that work I did is right.
But I lost you after you were first.
Like this one, the 5?
No, I just don't get this.
Why didn't you say something right away?
No,
Notice how I
I
stopped
got it.
repeatedly. It's
I
like, how are
got
we
it.
doing?
I got it until you started writing something about that one.
This one here?
Yeah.
Okay, so what I did here, okay, so I found my y value, right?
But don't you have to have 2 coordinates? Oh,
Yeah.
I'm not graphing though.
No, but you need an x and a y. So what I did, Aisley, is I then take my y value,
Okay, never mind. Yeah, I get it. Yeah.
then I plugged it in up here to solve for x. Okay, and then I plug it out. So I plug that in here for y. That's what I did here. So 2 minus 2y, so 2 minus 2 times 5. And I solve for x. Okay, we'll do more. Let's do another one. Let's do it again. That was so much fun. Let's have a second go. Okay, yeah. Next example. My first equation is 2x minus 4y equals 7. And then my second one is 4x plus y is 5. All right, we're going to try a little color coordination here. So which variable out of these two equations is the easiest to get by itself?
Y on the bottom.
Y. Blue y, right? All I need to do is bring that 4x over to the other side. If it's positive, I do that by... So this now looks like this. Okay. So this is the equation I'll use to find my y value in the end. Okay? This is what I'll come back and use the second time around. Got it? Cool. All right, so now I know what my y value is. I'm now going to take what y is, and I'm going to plug it in for this guy. Okay? So that's going to look like this. Dude, my fancy colors. 2x minus 4 times 5 minus 4x equals 7. So do you guys see what I did there? I got rid of one of the letters. We know how to solve in math for x or y at one time. We have no way of solving for both x and y at the same time right now. So you have to get one of the variables gone through substitution. Okay? All right, cool. I'm liking the energy in the room right now. I can tell you guys are following and feeling good. We're having a good time. We're glad we came on the cold day. That's the spirit. Thank you. Look, the excitement's just bubbling out of Jackson right now in a gaseous form from his mouth. All right, so first step. Boom, boom. Do a little distribution. Okay, now we combine like terms. 2x plus 16x. 18x. Oh, I forgot about this. This textbook's the one. All right, now I'm going to bring the 20 over to the negative 20 to the other side. If you write it in a different order, don't worry, it's all the same. 18x. I'm going to add 20 to both sides. 27. Now, with this stuff, normally I'd be like, keep it as a fraction, keep it as a fraction. If you want, you can write it as a decimal. I got to divide both sides by 18, right? These cancel. 27 divided by 18. You could write it as 1.5. That's what you'll actually get when you use your calculator. Or, you want to try 3 over 2. Dealer's choice, I don't judge which one you use. Okay? So now, I've solved for x. I need one more part of the coordinate, right? Very good. Are you saying letter y, or are you like, why do we need to do that? I know, it's one of my favorite math jokes. Never gets old. Killing it. All right, so now I take this and I plug it back into this equation here, right, guys? Right? Thank you. Yeah. It's so quiet in here without Connor. Really, that guy's like my one-man answering machine. So 4 times 1.5 is 6. So 5 take away 6. That's a tough one. Power through, it's -1. So my coordinates now are 1.5 and -1. And if you want, you can do the check as well. Now, on the test and everything, I don't make you do the check. The check's there, though, to see if you're right. Because if you do all this work and you get the wrong answer, it can be frustrating. But sometimes you can go back and find your mistake right away. All right? So check is optional, but highly, highly recommended. So recommended. How you guys feeling?
Do one more.
One more?
It was easier than the graph.
Yeah, you know what? I have to show you one more method after this. Most people like substitution the best. Until I do something like this.
Like that.
I don't think so. But I'm kind of weird. So, you know, I have a math degree. I like to run. I don't know. I'm a weirdo. So, and I drive a blue Focus. So what do I know, right?
And a Civic.
Yeah, and a Civic. Don't knock the Civic. I don't know what you got against the old Jap scrap there, Jackson. Civic will get you where you need to go.
After taking in the shop a few times.
No way, man. Those Honda engines, they go forever.
Like a V10.
Sure. I don't even know what that. I'm kidding. Okay. So, you're given fractions. You need to get rid of the Are you texting on your watch?
No, I was pausing it.
Oh, okay.
I could hear it.
Oh, that was your.
Yeah.
I just assume now when everyone's looking at their watch, they're texting or something.
I don't even know how to do that. Every time I say that, I
I
just
got
get
a text
confused.
message. I think Avery just texted me.
Oh, yeah.
That's probably your mom, Jackson. I'm always checking mine.
Do we have to do this? No, this.
Like that there? Yeah.
You have to write that down?
Yeah. Why would I write it down if you didn't have to
I
do
thought
it?
you said this was for later.
No.
Oh, Matt.
No. What? I never said later.
Yeah, you said until we have to do this, not Ricky.
Oh, now now we have to do it. People like this until I do this. And now that I'm doing it, that's fine. There's only 2 of you in the room to get mad at me, so I'm not too worried. So there's like 10 people being like, that's not fair, fractions. Then I'm
It looks stupid, really.
there we go. It's a good life skill. Judge everything before you even try it. Okay, we got to get rid of the fraction.
Divide it.
Say that, what?
Just divide them.
Not divide them, you multiply them.
Why can't I just divide them all? Because then technically they would all be divided and they would all be numbers.
But they already are, like, this fraction means 1 divided by 2, right? So they're already being divided. So you can't divide the divide.
Yeah, you can.
Yeah.
But if it means that, why don't we do that?
Just watch. To get rid of the fraction, you multiply each equation by its common denominator. Okay? So what's the common denominator for the first one? For 2 and 3, what's your common denominator? Very good. 6. That wasn't hard at all, was it?
It was pretty tough when we were different.
All right, you can take it easy. Easily, you're the only one left in the room now. What's the common denominator between 4 and 3? Very good. Okay? Boom. It's just so painful. So now all you do is you multiply all of this by 6. and all of this by 12. Okay.
Do you keep the fraction then, or do you take it away?
You can get rid of the fraction. Some people need to do the getting rid of the fraction in 2 steps. Some people can do it all in 1. What's 6 divided by 2?
Or divided by 3.
Becomes 3. So that's now, this one down here is 3x. What's 6 divided by 3? So what's 2 times 2? Okay.
And why? Oh, okay, it was a 5.
And then 6 times negative 1? Negative 6. Thanks, guys. You guys see what I did there?
Now you put your hand over your mouth.
No, for the fraction part. Okay. The other way you could do it, like, I'll do this one down here in red. So 12 times y. Very good. So this here would be, what's 12 divided by 4? Right. 3 times 1 is 3x. And what's 12 times, or sorry, what's 12 divided by 3?
4.
So then it's 4 times 5. Negative 20. Okay. Do you guys know that rule for fractions? Like you can simplify the numbers before you multiply? Okay. Otherwise, what you could have done here for this part, like what's 5 times 12? I'm just going to show you guys over here what this looks like. 5 times 12 is 60. And it's divided by 3. 60 divided by 3 is 20, which is the number down here.
Oh.
Does that make sense?
Yeah.
Oh, okay, right on. Okay, now, with this one, is there an easy way to get one of the variables by itself?
No.
Just say no.
No, but
Very-
technically the bottom one because it's like already on that side.
I would take the bottom one, but I wouldn't solve for y. You know which one I'm going to solve for?
X.
3x. Because look, I got 3x there, and I got 3x there. If they're the same, it makes it a lot easier.
Cool.
Watch. Okay, so I'm going to get 3x here by itself. To do that, I got to bring the negative 20 over by. Right. So when I do that, this becomes 12y plus 20 equals 3x. Now, if you look, I have a 3x here and a 3x here. I know what 3x equals, right? So I can plug this in here for 3x. Does that make sense? So I can take this one here and just put it right there. So it's like this, 12y plus 20 plus 4y equals negative 6.
Wait, so that's for the bottom one?
I took the bottom one and put it into the top one.
So one 3x.
No, I don't need to put the 3 out front this time. I don't need that? That's wrong. Bad 3. Get out of there. All right? Get. The reason I don't need the 3 there easily is because I see here how both these numbers have a 3 in them. The 3x and the 3x. That sounds weird. Because they both have a 3, they're the exact same, so I don't need to put the 3 back out there. They kind of cancel each other out. Okay?
Sure.
Yes, Spirit, sure. Just say what your teacher wants to hear. Thank you. All right, now we can just solve this, right? 12y plus 20 plus 4y equals negative 6. Cool, Mr. Weber. So now I combine like terms. 12y plus 4y is. Yes, very good. 16y. Is this supposed to be a fraction? Oh, these are terrible. God, I hate this book. 16y equals -6. I gotta bring the 20 over by subtracting it. Then what do I do with the 16i? Or if you want, you can write that as a decimal. I'd do this as a decimal.
How do you write it?
You just go -26 divided by 16. -1.6. Then you just have to take that, plug it in for y.
We just do y.
We did x. Oh no, we did y. So you got to plug it in. Yeah, plug it in for y to solve for x. Yeah, good catch. You guys want me to do that part too?
Yeah.
All right. I like the enthusiasm here, guys. Now, it doesn't matter which one you use. Let's go with this one here. Now, let's do this one. I like the black one.
I thought we just did that.
Oh, yeah, we
mean,
plugged
don't-
it into that. Okay, so we got to use the red one. Very good, Avery. Thank you for catching my mistake. You're doing good. You're awesome. All right, so then we find that for x, we go 12 times -1.6 equals 3x minus 20. -19.5. Now I add 20 to that, both sides. .5 equals 3x. Am I going too fast? I'm going too fast. I feel like I'm going way too fast. Very good. Ainsley, now you're going too fast.
Can you tell me what it is?
Please. 0.17. Ta-da! How are we feeling? Glad we came in on a cold day? You're trying to be so mean, you guys. All I do is come up here and like try to help you. All you guys do is just shoot me down. All right, here's your homework for today. Hey, 425. 4, 6. And 19 AB. Alright. Cool.
500, yeah.